Good morning.
Good morning.
Is everybody doing okay this morning?
Excellent.
This morning I'm going to be talking to you about processors. First, I want to discuss a little about what a processor is and what it does. So, does anybody know what a CPU is?
Central processing unit.
That's it. CPU is defined as a small chip that resides in computers and other electronic devices, controlling all the functions that drive that device. The most basic job of the processor is to receive input and distribute the appropriate output. It's pretty impressive how the small little chips are able to control devices that are many times larger than them. The key is the components that go into the processor itself. Before going into the individual parts of the chip, I want to show you a small video about how the processor is made. Pretty intricate and delicate process, isn't it? I'm going to break it down a little bit for you because it was a bit confusing to watch. Basically, they begin with a material called silica sand, which is pretty much just a type of sand, that is formed into an ingot of silicone. And the silicone ingots are then cut into wafers and polished. Then the wafer is exposed to a UV light mask, which engraves the texture for what will be the microprocessor's transistors. After that, the chip is bombarded with ions in order to change its conductive properties and create the surface of the transistors, forming a layer of copper on top of the insulation. All the transistors are now connected in an architecture which allows the chip to function like a processor. The chips are then tested, and then when they are deemed passable, they are fitted with a substrate and a heat spreader. After more strenuous testing, they are now ready to be shipped off and sold. Next, I want to talk a little bit about the components of a processor. Processor is composed of just a few basic parts, however, all the parts are essential to the chip's function. The three basic parts of the processor are the ALU, or the arithmetic logic unit, the control unit, and the registers. The arithmetic logic unit performs math calculations such as subtraction, addition, division, and other logical comparisons. The processor transmits signals to the ALU, which interprets instructions and performs calculations. Control units receive signals from the CPU, which instructs the control unit to move data from the microprocessor to microprocessor. The control unit also directs the arithmetic logic unit. Control units consist of multiple components such as the decoder, clock, control logic circuits. Working together, these devices transmit signals to certain locations on the microprocessor. The registers are basically temporary holding places for the processor. These memory areas contain data, such as computer instructions, storage addresses, characters, and other data. There are also other important parts of the CPU, namely cores and cache memory with newer CPUs. A CPU cache is used by the central processing unit of a computer to reduce the average time or energy to access data from the main memory. A cache is smaller, faster memory, basically. It's closer to the processor core, which stores copies of data from frequently used main memory locations. A core is basically the processor inside the processor. But a processor with one core can only work on one task at a time. But a multi-core processor can work on multiple tasks at any given point. One vital concept that makes processors infinitely more effective is hyper-threading. Hyper-threading is the splitting of a core into separate logical cores, making the cores twice as efficient. Next, I'd like to quickly talk about the four basic functions of processors. They have four primary functions: fetching, decoding, executing, and storing. Fetching is basically when the processor goes out to the memory and takes from that. Decoding is basically when the processor decodes programming into binary code from the application itself that's receiving the input from. Executing is when executing instructions from a program, the processor does one of three things. It performs calculations using the ALU, moves data from one location of the computer's memory to another, or moves different addresses within the computer's memory. And then storing is once the processor has an instruction for a program, it must give feedback in the form of data output. The source data is then written to the computer's memory for later reference. Who makes processors? Pretty much the only two big ones in desktop and laptop systems are AMD and Intel. Of course, there are other ones like Qualcomm Snapdragons for phones. They're pretty big in the phone market. And then I do want to talk a little bit about the constant game of leapfrog that's played by AMD and Intel as far as marketing goes. AMD and Intel are constantly making passes at each other by making better CPUs than each other in the particular quarter. one makes a better CPU that's surpassing the other, and it's kind of just a never-ending cycle. However, a processor that was made by one cannot be truly pitted against another as far as AMD and Intel goes, just because they're all different architectures and they can't be pitted against one another because of that. They're all basically optimized for different software. There's a picture of Intel headquarters as well as the AMD headquarters. They're both located in Santa Clara, California. And there's a couple of the current processors that are in circulation at the moment. This one is the Ryzen 7 2700X, and then this one is the Intel Core i9 9900K. They're pretty similar as far as specs go. I'm just going to show you a little bit of what's going on here. The Ryzen 2700X has 8 cores. It has a maximum boost clock of 4.3 gigahertz. It's got a total level 3 cache of 16 megabytes. The socket that it fits in is the AM4 socket. And the default power that it takes up is 105 watts, which that's quite a lot. And then the 9900K, it's about the same as far as specs go. It has 8 cores, just like the Ryzen. It's got 3.6 gigahertz base clock, and cache memory on it is 16 megabytes. And then it also uses about the same amount as the Ryzen does. And that'll conclude my presentation.